it's not just about the ethics of, what kind of data you have, whether it's terrible, toxic text from the dark web or whether you've stolen it from people or not. Machine learning 101 is that you don't test on your training set, right? So if you're testing how well your model is doing on a specific task, you have to make sure that the data in the test set does not have overlap with the training set, because otherwise it's like studying to the test.
Hello and welcome to Why Is This Happening with me, your host, Chris Hayes, and welcome back to our special With Pod series where we take an examination of AI and all of the embedded questions, complications, themes, worries, aspirations relating to our economy, our society, our culture, the technical implications, the philosophical implications. This has been a really joyful project for me because I like learning stuff and I feel like I'm getting somewhere, and I hope you guys feel the same way too. There's lots of ways in which the AI discourse can feel. I had a friend who's a therapist who said it gave her the feeling of avoidance, which I thought was interesting. And I can get that too sometimes. But then when you sort of pierce through that and do it in the way that I think we've been trying to do, I've really been enjoying it. One of the challenges in the whole discourse is basically this. There's a bunch of really fairly complex and sophisticated technical questions that can be, I think, a little difficult for people who are non-technicians to get their arms around. The people that have expertise, almost as a matter of sheer self-selection, and B, financial incentives, tend to be pretty big boosters of the technology. And again, I don't say that because I think people have bad motivations necessarily. I think that if you're working 100 hours a week at Anthropic and have the possibility of hundreds of millions of dollars in future wealth from it, you're going to be yeah, this is great. And so it can be hard to find people that do have real technical expertise, have worked in AI and around machine learning particularly, and large language models and things like that are more skeptical of the development of the technology in the way it's being developed right now specifically. Embedded in the companies is embedded using this kind of hyperscaler model of ever more data training that has more and more resources attached to it. And also in a specific, we should say, very distinct sociological milieu, which is the hothouse world of Silicon Valley and the frontier labs, which are overwhelmingly male. They are places in which Black folks and Latino folks particularly are incredibly underrepresented. They are places that have a very specific, distinct, and I think pretty acute culture around them that are part of the embedded universe that all of these very consequential decisions are getting made. And so my guest today is someone who you may have heard of a few years back. There was a story that kind of came out about her leaving Google, where she was co-lead of the ethical AI research team. She published a paper that Google kind of disavowed, and she had to kind of retract. And this was the first inklings, all before ChatGPT, this years ago, of some of the kind of rumblings of discontent within people working in AI about the trajectory it's on. Since then, she's gone on to do a bunch of really interesting things. She's right now the founder and executive director of the Distributed AI Research Institute, which is also known as the DARE Institute. Her name is Timnit Gebru. She has a PhD from Stanford University. She's been working in computer science, tech, and AI for most of her career. Timnit, it's great to have you on the program.
Thank you for having me. So much to discuss. So
I want to talk about the paper and this paper that you co-authored and the critiques embedded in it, because they have, I think, in some ways proved to be prophetic and also have created a kind of, let's say, a tendency or faction in the AI wars, right? Because the discourse actually is pretty polarized. So it's one important part of understanding the kind of discourse around this technology. But before we get to that, I'm curious why you were attracted to thinking about these problems at an intellectual level. I believe it was vision, right, that you were first sort of working on. But what is enticing about it as an intellectual problem to solve or think about?
Okay, so yeah, I mean, I was just thinking about it as an interesting technical problem. I mean, when I was taking classes in computer vision, we were working on things like pedestrian detection. And now you're thinking, oh my God, that sounds like surveillance. That sounds terrible. Why are you interested in pedestrian detection? I wasn't thinking like that. I'm like, so cool. Look at how many pedestrians I detected. And imagine, I mean, I remember looking at a program that could identify the number of coins that you have in an image. I don't know if other people would be super interested in stuff like this, but I'm like, oh my God, I could write a program that counts, that circles, that puts a circles around each of those coins, you know? So a lot of people in this field, I feel, are like me, you know, we come to it from a really interesting puzzle solving, how can I solve this puzzle technical interest. And so you mentioned a little bit about, you know, financial incentives. And now if your technical interest intersects with something that people claim is the most important thing to work on, sign me up. And
Right.
then they say like, you know, you have to be paid $1 million a year because at least because it's the most important thing to work on in the world. I mean, why wouldn't I want that, right? So that's kind of a lot of what we're dealing with right now. But I wanted to answer your question more broadly. When I entered the field of I didn't even think about it as AI because back then, most of us identified ourselves with the specific specialty that we were working on. So I would say I worked on computer vision. I wouldn't really say I worked on AI because what I worked on was very different, for example, from people in machine learning. And people in machine learning would say that they worked in machine learning. They wouldn't say AI. In fact, machine learning was not considered AI because I'm gonna like
Please.
roll back a little bit. AI is this marketing term that you know you have a bunch of collection of things that are upgraded and downgraded from AI. So when one of these things is somehow gets really good performance in a benchmark or something, it gets upgraded to AI. And then when we have what we call the AI winters, where nobody cares about AI anymore, or you have unfulfilled promises, it gets downgraded. So, for example, in the 80s, machine learning was not what people were calling AI. It was these things called expert systems. Nobody calls expert systems AI right now, right? So back then, the machine learning people were pretty annoyed that all of their papers get rejected by so-called AI journals. So they created their own journals. So this is the kind of history we're talking about, right? So,
But I wanna ask you
mhm.
about that though, because I think what I'm hearing in your description of that is a description of fashion. Things come in and they come out of fashion.
Exactly.
Well, but isn't there an argument that partly it's progress in this sense? Like the expert systems sort of failed to deliver, the machine learning stuff, you know, there were big debates within this world, right? About sort of rule-based systems, expert systems, neural networks and large language models, which was going to kind of be able to kind of replicate the things that we want the most, right? You know, whether that's passing a Turing test and sounding like human or being able to give you usable identifications of pedestrians or whatever it is. And it seems to me like one of those theories got borne out. It was not the one that was very popular at a certain point. In fact, for a long time, the kind of like the neural network and sort of machine learning people and the kind of like just get a bunch of big data, do pattern
Mhm.
recognition, iterate, were kind of like the dead end. But then the dead end kind of had breakthroughs and the other people looked like a dead end, right? I mean, there was actual progress, I guess.
Right. So that's what I want to say is that every time there is a specific kind of progress on a specific benchmark, that thing that makes that progress ends up being called AI, right? So for example, when you have something that wins a chess match
Yeah.
against humans, that becomes AI, and then it doesn't become AI anymore because that progress is no longer thought of as so-called AI. So it's both some amount of progress in specific things and going in and out of fashion because there's a specific thing that people associate with AI, which is this nebulous thing that they don't think it's something that is solvable by a machine. And
Right.
once the thing proves to be maybe solvable, and like we have to get into this too, because there's a lot of hype too, there's a lot of claims that are unsubstantiated as well. But once things are solvable, then they become AI. But the thing is that a lot of times I advocate for not using the term AI and being very specific about what we're talking about. So, for example, speech recognition, where you all we do is transcribe the speech, right? Very clear definition of input, output, what the thing is supposed to do. I would just call it speech recognition. So you make progress on speech recognition, that's great. Machine translation is one, translating from one language to another, or face recognition is another specific thing. Right now, all of these things are lumped into AI along with ChatGPT, right?
Right.
Along with video generation and things like that. And so when we lump all of these things into AI, it just makes the conversation very difficult because when we're talking about the harms of AI, which harms of which AI are we talking about?
Right.
You know,
Right.
we're talking about cancer detection with very specifically trained image recognition models, or are we talking about mimicking a human, which is a very dangerous thing to do? I'm realizing you've learned a lot from your from your series because Weizenbaum, you might
Yep.
Weizenbaum warned about mimicking of humans because his very simple Eliza chatbot was very dangerous. He saw how
Yes.
people were getting attached to it.
This is one of the first chatbots that's produced. Is it in the 1970s, I think?
Yeah,
Right?
exactly.
And
And
it's
so
very basic. It has these like super basic. It's basically if you program it all, it's just like a case programming, right? Like if they say one of these things, say one of these things, sort of a finite set of steps. So extremely rudimentary, right? If a bunch of if then statements, case statements. But it turned out that again, people had not done this before, and you gave it to them, and when people first interacted with this, again, extremely rudimentary. Anyone learning coding could probably do this, very early on. People were like, whoa, it's the machine is talking to me. It's alive.
and they got very attached to it. And so Weizenbaum spent the rest of his life warning about these kinds of systems, warning about people, what we would call, I guess, AI boosters right now. So I highly respect him because he is someone who understood the issues with the thing that he built and was warning about him. And unfortunately, we have very few of those people right now because, like, if you talk about Stanford, for example, my alma mater, Stanford is the same as Silicon Valley, is the same as Google, is the same as OpenAI. I mean, you would hope that the academics are a little different from industry and that there is someone out there who is saying something differently, like they're not all rowing in the same boat, right? But we're right now in a situation where it's very difficult to understand what is real and what's not real because not many people are invested in really informing the public.
Here's my understanding, and again, this is a rudimentary understanding, but I want to see whether I'm misunderstanding. If you talk about, say, natural language processing, right, which again, it's funny because these were all problems when I was like in college that were like confounding problems. It's like, these are really hard problems. We don't actually know, we can't, facial recognition. Humans are incredible at recognizing faces. We don't have a great theory of how and why they are. Natural language processing. I remember taking courses of that in college. Pedestrian identification, right? So these are like discrete tasks. My understanding of why, aside from marketing purposes, these are being sort of grouped together is that they're all places in which this kind of brute force method has borne some real fruit, which is you create some sort of model and you feed it a bunch of data and you intervene to correct it. You say like, no, that's wrong, that's right, that's wrong. And over time, these kind of connections get built up such that it starts to get very good at, say, predicting a pedestrian or, taking speech and making text or recognizing cancer growth. And that sort of approach broadly has borne a lot of fruit and is being used in a lot of different areas. Is that
That is, I would say that's true, but I don't think that's the whole picture because for example, let's say 15 years ago, so this methodology that we're talking about is machine learning, right? Statistical machine learning. And machine learning is a technique, right, that is used for many different things, just like statistics is a technique that is used for many different things,
totally? Yep.
right? And so, for example, in computer vision, the way in which people used to do image recognition, for example, wasn't using machine learning before. They didn't use a lot of training data. They would use machine learning. And then within machine learning, there's the deep learning, neural.
Mhm.
Deep learning is a word that was created because neural networks were too stigmatized by the rest of the
Yes,
AI
I know.
industry.
No, it's so funny. They were like completely the like orphaned child, right? An
Yeah.
intellectual dead end.
And they called it deep learning because neural networks was
Right.
a high correlation that your papers would be rejected if it had the
Right. It's
word term
amazing.
neural network. So, neural network is a subset of machine learning. So, a machine learning, statistical machine learning specifically, is a technique that a bunch of different people can use, right? And then that's one thing, that's the technique. And then there are the tasks. The tasks are, let's say, different kinds of tasks, natural and within natural language processing, there are a bunch of tasks. Within computer vision, there are a bunch of tasks. So a lot of people in vision and natural language processing didn't use what's called feature learning, right? So I'll explain very quickly what feature learning is. So what we used to do is, so what we need is, let's say we have to figure out how to classify, I don't know, oranges in an image or something.
Yep.
What we would do is we first would create a transformation of the image. So a set of numbers was each such that each image is represented by a set of numbers,
Yep.
and we would calculate those numbers by hand. So you would give me an image, and I would figure out, using my knowledge of light and transformations and mathematical transformations, whatever, I would use a specific method to transform that image to a certain set of numbers, which are called features. And
Mm.
then that means that in this feature space, if I have two images, one is a set of image of an orange, another is an image of a car or something. If you compare those features that you transform those images to, they should be very different from each other. And if you compare the features of two images that have oranges or something, they should be very similar to each other, right? That's kind of
Yep.
transforming the image into a feature space. So then the deep learning people, what they do is they say, okay, let's do feature learning. So instead of you calculating this thing by hand using a predefined method,
Mm.
we use all of this data to learn
What the features are.
what the features are. Now, this is why it's not as explainable, right, as using a predefined methodology. You know the mathematical properties, you know what you did to each image to get those features, etc. So right now, so then the technique is lumped, that one technique of feature learning is lumped in the same category as the task itself. You see what I mean? So it's yes, you're right that right now we're using that one technique for many things like this machine learning. But even before that, people in computer vision were lumped under AI. Because it was the task of computer vision, whether
Right.
or not they used machine learning. And the machine learning was not they were trying to be called AI, but it wasn't really working. So they weren't called AI. So the reason I'm like harping on about the word AI is that, for example, it makes it very difficult to have conversations about the things I like to work on and the things I advocate for versus the things that are harmful. So, for
Right. Right.
example, speech recognition, even though we use statistical machine learning, you can create a speech recognition system for a specific language using very low data. You can curate the data, pay all the data workers, not use so many computational resources, do it very carefully, and address a very important problem, which is speech transcription that helps a lot of people. And it's a very well defined input output. Now we have, it's very interesting that you brought out that we're using the same methodology for everything. I call it like a one model for everything type of approach.
That's totally, and that's what they say. I mean, that's the selling point. That's both the hype. That's the conception. Like the whole idea is this, you get enough data, you do enough training, you iterate enough, it gets bigger and bigger, bigger, scaling laws. You don't have to do little bespoke things for
Yeah.
this language. And that's the selling, that's what they're trying to bring
So
about.
let me give you a specific problem that we didn't have that has emerged because of this whole one model for everything approach. So with speech recognition, you can do a specific type of model architecture. You can curate your data. You don't have to guzzle everything up on the internet. You don't have to do it for like every, all 7,000 of the world's languages or claim. You can do it for specific languages, etc. Right? So in the past with speech recognition, there were issues like inaccuracies, and of course, it was, things that didn't work. But there wasn't this so-called hallucination where you just have large swath of text that are completely made up. And now with things like Whisper, OpenAI speech recognition slash translation system that's also integrated into ChatGPT, you have these issues where with speech transcription, or speech recognition, a very well defined. I like this problem because it's a very well defined engineering problem. Your input is speech, your output is exactly the text of that speech. That's it. Very well defined input, very well defined output. You have systems like Whisper that make up a whole bunch of stuff instead of just transcribing the output. So, for example, there was a very dangerous example where the speech said something like, I believe he was wearing a cross or something like that. And then the transcription says, he had a terror knife, he killed 200 people, you know what I mean? And so then you have hospitals using this stuff to transcribe notes, and they think it works really well because of what we call automation bias. They think it works really well. They overtrust the system because they're being deceived into thinking that it's
Right.
perfect. And they don't keep the audio, right? The initial audio recording. So they don't know what the description was. They have these notes that can be completely off and in a dangerous way. And that came about because of this whole one model
So,
for everything approach.
right. So these different models, right? I heard you talk about it, this sort of more tailored, discrete models for task specific, that they require way less in these sort of gargantuan resources. We all know, everyone has been inundated with information about how massive these data centers are. 7% of all U.S. electricity consumption happening in the country right now, 7%, it's up to 7% is our data centers. That's predicted to go up even higher, maybe 10, 15, depending if this all gets built out. I mean, you're saying that at a way less resource intensive level, you can pick discrete problems and use some of these same methods, right? I mean, the tech isn't that different. You're going to do some learning, you're going to do some training, you're going to have a data set to produce reliable, useful tools for those specific tasks, as opposed to the kind of bigger is always better, we're going to get some generalized intelligence. And
Yes.
my question about, so there's two parts of that, and this I think speaks to that original paper, which we can talk about, is like, there's both a engineering argument you're making about that, right? It's better for the task, but there's also like an ethical argument. Like there's a deep ethical political argument, it seems to me, that is suffusing all this. The engineering argument, which you just said, is like, it actually starts introducing problems that it shouldn't have. In fact, if you just were to scale it and tailor it for what you're doing, you could actually do a better job.
Hmm.
Walk me through why there's this sort of ethical valence to this, an ethical political valence to the always bigger, build more. And it's just a question of getting these systems big enough and scaled enough that they can start to produce intelligence that is generalized and looks like what humans do in every sphere.
Yeah, I'll walk you through that. And I have to say that I've learned more since I have written the Stochastic Parrots paper with my co-authors. But what was happening around the time when we wrote the Stochastic Parrots paper, which would be around 2020, was that we were at the height of the Black Lives Matter movement. And at the same time, OpenAI was releasing these GPT models. This is way before ChatGPT.
Yeah, before it blows up in the kind of public consciousness, this is like in the AI world, you're working there.
Yeah.
This is not in everyone's faces all the time.
No,
at that
nobody
point.
knows what I'm talking about, right?
Right,
Like
yeah.
nobody
Yeah.
knows what. But in my world, of researchers and and I was at Google, people are super excited by these GPT models. So there was GPT-2, but now GPT-3 has come out. GPT-3 is much bigger than GPT-2, both in the amount of data they consume and the amount of computational resources they consume. Because what it means is making your models bigger means that you have a more complicated mathematical function that maps your input to, a feature space or something. And so they make it bigger and bigger, which means the math is more, more and more, the resulting math is more and more complicated, which is also less and less explainable, right? So that means that you make it bigger in terms of computational resources. You need more basically computers and chips and stuff to train it, more energy, more water. And then you also need more data to train a bigger model. So they were, and so at some point in about, 2017 or something is when let me just back up really quickly.
Hmm. Hmm.
So OpenAI, the reason I've always hated them, like, sorry to say that, or disliked them, let's say,
Uh,
even though I was fired by Google. I wrote an open letter when they were announced in 2015 because I was so angry by how the press was describing them as literally a quote unquote altruistic endeavor because they started as a company that was trying to create artificial general intelligence, different from artificial intelligence, artificial general intelligence. But the biggest, the most prominent company before them that was started to create AGI, artificial general intelligence, was DeepMind.
yep.
So at the same time, their goal, they say, was they branded themselves as an AI safety company to basically stop fictional super intelligent machines from rendering humanity extinct, right? So all of this fanfare, Peter Thiel, Elon Musk, all of these billionaires were doing this. But back then, what they thought it wasn't language models that they were focused on. It was deep reinforcement learning. It was a different kind of technique. And so
Okay.
all of their experiments and if you look at it, it was all games like Go, AlphaGo, DeepMind
Yep.
had AlphaGo and this and that. So that the pivot to language modeling happened when Google came out with this Google Brain, the division I was in actually. Researchers there came up with a new architecture to do language modeling. And then after they came out with a new architecture, the year later, there was a new model, a precursor to GPT, let's say, called BERT, that kind of had good feature representations for a lot of different tasks. We talked a little bit about what
Hmm.
feature representations are earlier. So once BERT came out, um, OpenAI basically pivoted into working on large language models, and then they pivoted into making it larger and larger and larger. So 2020, there was already this race among all of these companies to build larger and larger language models. And I did not understand why this was happening. It literally looked like a pissing contest. I'm telling you, it was honestly. And so I asked Jeff Dean, who was VP of research at the time at Google, he presented at a research all hands and he said he was upset that OpenAI had the largest model and that this was a missed opportunity for Google. Google should have had the largest model. I emailed him and I asked, why do we care about having what is the largest model supposed to do for you? What research model like questions are you trying to ask? Because they were so fixated in the size and they weren't talking about what a big model was supposed to give you. At the time, the whole scale is all you need thing wasn't, really happening, but they were just still fixated on the size. So then on the other hand, on the ethical side, let me tell you the kinds of conversations that were happening. People were asking if GPT was ethical, which really pissed me off. Like, it's like, do you ask if a bridge is ethical?
Right.
No. And so I was like, this cannot be the kind of conversation we're having about larger and larger language models. And at the same time, we have Black Lives Matter going on. And there were papers that showed that GPT-2's, the precursor to GPT-3, was outputting extremely toxic and racist text. And nobody was talking about it except for a couple of people. And Emily Bender was talking about the fact that OpenAI was not transparent about their data. So both me and her have worked on advocating for documentation. And I have a paper called Data Sheets. She has a paper called Data Statements. And we said, basically it's very simple. Tell us what data you're using, document your data. Don't just gobble up. Like when you're making food at a restaurant, you don't tell me like, I don't even know if this has spinach or I don't even know if the spinach has E. coli. Like you don't do that, right?
Right. Right.
Oh, I don't know if I paid for the tomatoes. I might have just stolen them from the farmer's market. I mean, I don't know how we let
Right.
this happen. So we were just saying that people talk about documentation debt. They say, "Oh, we have to use all the data, and if we use all the data, we can't know what's in it because we can't. It's impossible to document all this data." And so, Emily was like saying, "Well, I can't say I can't study the properties of these models if I don't even know what data they were trained on." I want to say how important that is because it's not just about the ethics of what kind of data you have, whether it's terrible, toxic text from the dark web or whether you've stolen it from people or not. Machine learning 101 is that you don't test on your training set, right? So if you're testing how well your model is doing on a specific task, you have to make sure that the data in the test set does not have overlap with the training set because otherwise it's like studying to the test. Well,
Right.
if I gave you the 10 questions that you're going to have
Right.
to answer on your test, that doesn't mean you learned the material. It means you learned those 10 questions. It's very interesting because that's a very simple concept. Right now, it's gone out the window because we don't know what the training data is, but there's all these headlines saying, "Oh, it passed the math Olympiad." Well, I bet you it was part of the training data, right? Because it memorized it. So, this was kind of so. I wanted to make sure that our conversations were not grounded in is ChatGPT ethical, right? I wanted to collaborate with the people who were asking the right questions. And I wanted to ask people, why are you fixated on size? If you're fixated on size, please think about all of the things that could go wrong if you're fixated on size. And I want to say that back then, we weren't writing about chatbots specifically. We were just writing about large language models. And I think that also muddies the problem, the conversation, because right now, people who are offended that we called large language models stochastic parrots. And for us, it's not a derogatory term or anything. It's literally a descriptive term to say, this is how large language models work. This is how they're trained. They're trained to reproduce the most likely sequences of text based on the training data. This is, the calculate the most likely sequences of text. This is how they work. And that was the reason Emily came up with the term stochastic parrots
Right.
because we thought it was descriptive. Now, of course, then there's chatbots, there's all this other stuff. So our goal was large language models that are used for anything. They're also used for speech recognition. And we like speech recognition. We have in our paper a section about, dual use. If there are good uses of this technology, like large language models, let's think how big is too big? Does it need to be this big in order to achieve those good uses?
But is the too big is a concern about resources? It's a
Let me just define what big means, right? Big is in terms of your model size, is the number of parameters that you have in your model, and also the amount of data points that you're training for your model. So we were literally talking about how big is too big. We're not talking about whether large language modeling itself is a dangerous task. We're saying what are the risks that we need to think about and the harms of large language models, the larger and larger you get. The first thing we discussed is the environmental and financial cost.
right.
When your model is big and you're using lots, because the cloud is not like in the clouds, right? I mean, it's an actual place.
Physical data centers.
It's
Yep. Being
actual
built all
data
over the
centers.
country. Yep.
Exactly. And at the time, all of these data centers that we all know right now, we know Google and Microsoft and all these people have abandoned their carbon neutrality goals that they said they were going to reach in 2030. And they've abandoned them. We hadn't even gone there yet. But we were seeing where we were headed if we were just prioritizing size. So when you have size, that means that you're going to need more computational power. That means more electricity, more computers, more chips, more GPUs, whatever, right?
Yeah.
And so that creates a problem because we talked about, for instance, environmental racism. The people who pay the cost are not the people who benefit from any of these systems, right? The people in Memphis, where Elon Musk data center is, that are getting asthma and all these other problems, and that whose electricity bill is going up. They're not the ones making money from this. They're not the
Right.
ones benefiting from this. We also talk about the financial cost. Now we see it, right? OpenAI, Anthropic, all these people see it as their as their advantage, competitive advantage, because nobody else can buy this many GPUs and all of these. So we said that the financial cost makes it such that it locks out a lot of people into just doing this kind of research
Right.
or
This
work.
this fundamental approach, which is so dependent on size and scale,
Yeah,
requires a level of resources that mean that you can't have. It's not like, the classic example being the App Store, right? Where like basically anyone, and that's changed a little bit, but
yeah,
it didn't take a lot to like code an iPhone game. I know people that have done it. I've known people that have done it very successfully, right? Like extremely low barrier entry, a competitive place where people can come up with new ideas. This is basically the opposite of that because you're talking about hundreds of billions of
exactly.
dollars of fixed cost capital expenditure.
Exactly. That's the first thing we talked about. So when you
Yeah.
ask about size, what is it in terms of resources, et cetera? So the first thing we address is resources and the multifaceted issues that we have from consuming those kinds of resources. The second thing we discussed is the data. So size instead of huge data sets. What does it mean? A, it means you'll say you don't want to document it. It's too big to document. B, it means that, we have a section that says size doesn't guarantee diversity. There's this kind of misconception that says, oh, we have such a huge data set. We are capturing all of the people's humanity. I remember when Stable Diffusion came out, Stability AI CEO was saying, we just compress all of humanity's knowledge. Well, most of humanity is not even on the internet, first of all. So you didn't do that. And secondly, the kinds of places they got this data from, like Reddit, I got so harassed on Reddit. I never went on Reddit a lot of times. Social media platforms, certain groups of people are harassed out, and other groups of people are, censored, or like whatever data that you have on the internet is mostly hegemonic views in terms of language, in terms of culture. Marginalized views are kind of booted out, or not
Or less
amplified,
represented. Yeah. I mean, right. Yeah.
less represented in for many reasons. And so
Yeah.
size doesn't guarantee diversity. And then we talked about all of the toxic text, and also even the issues with the way they were filtering things out. So for example, they would filter out texts for toxicity based on terms. And what that does is it would take out websites or text where people are reclaiming those terms. So actually they did worse,
That's
right?
interesting. Yeah.
So yeah, and then the other really interesting thing we just
Right. If you took out blackplanet.com for the N-word, you would basically kick out
that's it.
blackplanet.com, which is one of the, great repositories of organic Black internet interaction over many, many years. Right. Yeah, I get it.
That's it. And also for queer people, same thing.
Right. Right. Yeah.
Exactly. And then the last thing we discussed is changing social views. A lot of times when social views change, people edit Wikipedia pages, people edit other things, but these things are kind of dwarfed by the bigger unchanged text, and also they might not make it for the next training data in time, and so you're sort of locked in to like the older, after Me Too, Black Lives Matter, etc. You're sort of locked into pre that era, right? Because you're not adjusting your training data fast enough, and you're not curating it to get that kind of data. So we discussed a lot of things with respect to the data. That was the biggest section. And then we talked about two things, I would say, that were important. One is the Weizenbaum kind of thing we talked about. And this was more, I'm not a cognitive scientist, so this wasn't really my contribution. But Meg Mitchell, who was my co-lead and then got fired, and Emily Bender, they both have a linguist and NLP background and also some cognitive science background. So they talked about how people imagine a mind behind the text that they see. And when
Yes.
it's fluent, so the issue with larger and larger language models is that you don't have a cue, a cue that, for example, in machine translation, when something is translated the wrong way and the grammar is incorrect, you have a cue, oh, this is probably wrong, right? But when it's super fluent text and it makes sense to you, you don't have a cue that it's wrong. So we actually gave this example of a Palestinian man who wrote good morning and it was translated to attack them, right? Like it's complete.
Mhm.
And he was arrested and later released because of automation bias. They didn't even check to see what the non-translated version was, right? Because they didn't have any cues that the grammar was wrong or anything. They overtrusted it. So we talked about the kinds of issues that may occur from this kind of mimicry, and like people imagining a mind behind it. And the last thing we discussed is really what kinds of great research are we not pursuing by going through this singular direction? Literally, just
Mhm.
the only direction that you're supposed to pursue in the field of AI that you could do so many things in is this singular direction.
I mean, what's interesting, the irony there, right, is that a lot of the things that have contributed to this particular singular direction were extremely frowned upon, out of fashion, rejected for very many years, and viewed as kind of, uh,
Absolutely.
a dead end.
Yes, no, not even that, by the way. In around 2012, when so what happened is the neural networks got really good performance on a specific benchmark that came out of the lab that I got my PhD in, called the ImageNet data set. And even after that, in 2012, Jan LeCun, Jan LeCun used to be chief scientist of Meta
Yep.
and like godfather of deep learning or whatever.
Right,
Okay,
right.
so Jan LeCun wrote an open letter to the computer vision academic community after one of his papers got rejected. He was really upset. He was like, "I'm never going to submit my papers to this conference." And you know why people rejected it? These methodologies. It was because they could not explain why these things worked as very well, and they could not give you the properties of these models. And it's sad because we still should be asking for those things, right? But now that's it. Like every single method sort of has been redirected to this paradigm. And people are not asking this kind of question like, well, but you can't really explain to me why exactly it's working that well. All you can explain to me is that you have this training set and then you train this thing and it does well on your test set. Like, why can't you tell me more things about the model than this? And that's part of why these things were being these methodologies were being rejected back then, even after they showed good performance.
I mean, but doesn't that get to the heart of the whole thing, right? I mean, what they're saying is, I mean, to sort of give, the other side of this argument is that like that's what's incredible about essentially this emergent properties that come out of scaling at this level, that like you start to get behaviors that you can't account for.
I'm gonna stop you right there because
Well, I mean, I'm just saying that's what they say. I'm
yeah,
not
yeah,
saying that's true.
but no, I know. So I will answer that. Okay, so this is one of the things that really irritates me about this field, right? Because I used to be an electrical engineer, and in electrical engineering, you really kind of model things. You write out like what you expect the systems to be, and then you check, how your model compares with reality, and you model different kinds of errors, and you do all this stuff. And in physics, same thing. So in physics, there's these words like phase change. What's phase change? It's a very clear thing when a thing goes from being a solid to a liquid, or
Hmm.
liquid to a gas. That's phase change. In this specific case, they're making up all these words without explaining, without actually seeing whether it is what is emergent change. Well, the graph was like this, and now there's a slope, and now it became here, and this part is emergent change. And there was a paper that got a best paper award at NeurIPS, which is the biggest machine learning conference.
Yep.
That's where all of these deep learning people
Yep.
now publish their papers.
Yeah.
There's a paper that got best paper award from Sammy Cuejo and his students and collaborators. I don't know, one of them might be a postdoc, that showed that um, basically these emergent properties that they said it until then were basically like a mirage. They weren't looking at the right metrics. They weren't looking at the right scales and things like this. This is why I mean it's very sloppy
Hmm.
work and science, and it's just misinforming the public, right? If I can't even see your training data, so you might be testing on your training data, and then you're telling me there's something called emergence just because you did the wrong thing, and nobody even checked it. The paper that showed that has to get a best paper award. Why would I believe anything else you say?
But in terms of like what they're doing now versus what they could do before, like there just is this, whether it's a good thing or not for the world, like there are things you can do now with these models that you couldn't do 3 years ago. I mean, just or even a year or two ago. I mean, and So I don't know if the scaling laws are working. I don't know if if the whole thing is a mirage, but obviously 6 years ago, you couldn't really get, you know, it to write a book review of a PDF you uploaded at 300 pages. It just wouldn't really
Yeah, but
work,
is that
right?
really a book review though? So here's the thing.
Well,
I think
whatever it is, I'm just saying that
yeah,
you
yeah.
couldn't even get the
I
simulacrum of it, right?
I,
You
I
couldn't.
don't
Yeah.
dispute that there are things that are happening that couldn't happen before, etc. What I'm disputing is that there are, like, for example, there is another claim about reasoning. And my old manager at Google, who's now at Apple, all of his papers about how this reasoning thing does not exist because they're doing sloppy testing.
Right.
So actually, if you just change like the plus to a minus or something, it fails, right? So there's also overfitting.
Explain. Wait. Take a second. Explain overfitting because that's a huge
Okay,
part of this. Yes.
yeah, overfitting is like, for example, like I said, studying to the test, you've
Yes.
basically memorized it and you're not really testing the right thing anymore. And so to me, there's a couple of things going on. One is, yes, there you can't dispute that there are certain things that are better, but you don't need those things. If the things that I think we want, like speech recognition or very specific, cancer detection or whatever, they don't need to exist with this other paradigm. Like they don't, we don't need to do all of this resource consumption, etc., to get the things that we think are good. Secondly, there are things that are happening now, but that they're not good, right? Like the addiction, the chatbot addiction, the mimicry of people, that it's just not good. And thirdly, um, there are so many claims that are unsubstantiated and they're coming from untrustworthy people that it's really hard to know what claims are actually true because we don't have the data. They won't release the data. We have to take their word for it with respect to the testing. And then, when you have academia is like completely failing, um, and, there's also like the naming of aspirational things versus actual things. Like, for example, when people say, um, it writes a summary or a literature review. Maybe and I don't know how much of it is correct, how much of it is incorrect. But, like, for example, when I ask someone, a student, to write a literature review, I'm not just doing it because I want an artifact that's a literature review. I want them to go through the process of doing that because they learn something really important in
Yes.
synthesizing. So there's just a lot of different things bundled up, is what I'm saying, in
Yeah.
what's going on right now.
The I mean, the resource thing to me, the place where it seems craziest and most obvious. I mean, there was just reporting recently about how, you know, Claude it's costing $5,000 a month for things they're charging $200 a month. The craziest version of this is
I
that
mean,
if you ask for a recommendation of a restaurant in Seoul, South Korea, like Google will show you a bunch of websites that have it, including probably a decent Reddit thread or some thread somewhere where people talk about it. And then they have Gemini summarizing it up the top and giving you some suggestions. But it's like 100 to 1, the
right.
compute of that little thing at
Exactly.
the box to the other things. So what's interesting to me about it is any efficiency or cost considerations have basically been thrown out, which is a strange thing that doesn't happen very often in either the
Yeah.
business world or the tech world or even the engineering world. Like, it's always the case that resource constraint, doing things in the most efficient manner, are just pounded into everyone.
Yeah.
Even when you take your first year CS class and
That's what I
you're
was
running a
saying.
search or a sort, it's yeah, do
Exactly.
the most compute efficient way of sorting this.
Yeah, I was in a Bloomberg interview when the whole DeepSeek thing happened, telling them exactly that. That's why I got excited about this field, is because you take an algorithms class and the goal is to do the most clever thing possible. And right now, okay, yeah, you can do this with the brute force way with all the resources available, but now try it the more clever way. What's the fastest way you can do it? What is the, how little memory can you use? Right, where we are right now is the complete opposite. How big, if we can't mine everything on Earth, let's try to go to Mars. What about the moon? Like, that's where we are. And it's just really not exciting for me. And the reason the DeepSeek thing was super interesting.
That's the Chinese model that was produced on
Yeah,
way, like orders of magnitude fewer resources,
exactly.
essentially.
That was interesting because you can see what happens, how you can innovate when you're resource constrained. They really did innovate, and these people were very like sore losers. I'll tell you, the academics, the Europeans and the Americans were like, well, when you invent something and then the Chinese can copy it or whatever, that's not what they did. Because if that came out of DeepMind or something, I'm telling you, it would be like on the cover of some magazine as a breakthrough because they did a number of innovations. They didn't even use NVIDIA's library, CUDA library, which most people use. They really optimized the hardware. So that's super exciting to see that, it's possible to do something differently. However, they still kind of were working on the LLM part of the large language model paradigm. And I'm like, well, if your creativity was like on something different, maybe we could have a different paradigm too. But that part of how showing how resource constrained they can be is what innovation means, in my opinion. It's not whatever's happening with these big companies.
If these models, if we hit, there's a bet being made that they can produce enough revenue that they can justify the capital expenditure. That's obviously the bet. I don't know if that is a correct or not bet. And Lord knows I'm not a betting man at all. Zero interest in it. Never have really been interested in it.
Good for you. Don't.
Well, people ask me all the time, like, who's going to be the nominee? And I'm like, I truly have no idea. Like, I just don't know the future. But
Yeah.
let's say the bet doesn't pay off. So let's just take the route. I'm curious to hear you
Mm.
on this. If there's a big financial, like basically they overshot and the finances of this crumble, right?
Yeah.
I guess there's two ways I can think about, obviously there's a bunch of things. There's two things that could happen, right? Like one is you can see this as like, okay, maybe that was a dead end or, and we start getting hyped about something new, whatever the next version of the metaverse is. Or that all of that, the sort of necessity mother of invention thing, like all of those old values that people had around compute power and efficiency and resource constraint and start to come back in to push this in new and interesting ways, which is to say, like, when you're not just sort of brute force hyperscaling, maybe there's another path that this takes that is interesting and innovative without that.
Perhaps, the reason we're on this path is because there's this bundle of ideologies that my collaborator and I call the TESCREAL bundle. I'm not going to go to, it's the transhumanists and the effective altruists, long-termists and all that. And what they did is I've been advocating for task-specific models as we discussed, and they lamented that the field had gone towards that direction. And they really wanted to create what's called AGI, which I believe is a machine god. I don't really know how else to explain it. I've never been interested in building a machine god. And now, if you are building a machine god, of course, you have to use all of the world's resources. Guess what? Because a machine god will just solve everything. Like, you'll build the thing that will solve climate change.
They explicitly say that, by the way.
Absolutely.
This is a view that this is not a caricature of the view. This is a view that Sam Altman said that his revenue plan, his profitability plan for OpenAI was to build AGI and then ask the model how to make money.
Yeah, and also Ilyas Escobar also said when people asked him about, how do you bake ethics into your work? He said at some point in the future, the model will tell us what is ethical. So and Sam Altman called it magic intelligence in the sky. Now in this camp, you have believers, true believers true believers. Who want to live forever and they think we can upload our minds and colonize the cosmos and stuff. And then you have people who I don't think are true believers, but they use that narrative to excite other people, right? So the thing is, on the one hand, you're saying we will build the machine god that solves everything. Of course, we have to use all of our resources.
Yes.
We might accidentally build the machine devil instead. And so you don't want anybody else to build the machine devil. You don't want China to build the machine devil. So you should make sure that we build the machine god. Like, not, the best the thing, what is it? Best thing to stop a guy with a gun, a bad guy with a gun, is a good guy with a gun, right? So you stop a bad guy with a machine devil is to stop a good person with a machine god. That's literally their argument. So that's how they push this agenda. I've to be honest, I've seen how propaganda works the best on this, seeing how this whole thing played out, because I saw these people for, more than a decade pushing this and slowly making it into the mainstream, because they used to be left out of the room even within the field of AI. The whole AGI thing was not at all popular. And when Elon Musk and all these people, Peter Thiel, started talking about how AI is summoning the devil and how we should worry more about AI than climate change, people thought they were ridiculous, right? But now it became mainstream. But now I don't think this line of conversation is really working out for them, because investors are asking about returns, right? And so now that's not, when they go to investors, they're not talking about good guy with a machine god, bad guy with a machine god. They're talking about how many people they're going to replace
Yeah.
with their machine. They're not doing that, right? Like, this good guy with machine god, bad guy with machine god, that's for the public, right? That's to get us on board. Where for the investors, but the thing is, a lot of what's been working is they just, you see how many people are hidden. Like, we work with people called AI impersonators. I don't know if you've heard of what they are. AI impersonators are people who pretend to be AI. Like, they pretend to be chatbots. So all of these kind of Amazon's, automatic checkout, which turned out to be actually people watching you. All of these people in the Philippines and Waymo's like actually watching and stuff like that, right? So what you're doing to a certain extent is obfuscating, to a large extent actually, the amount of human labor and data and grunt work that is fueling these things. And you're exploiting those people. You're not paying them. So it looks like magical and, magic
Right.
intelligence in the sky and all of that. You're not paying for your data. And then even with all of that, you're still losing money. I don't see how this will work out. And honestly, even if it doesn't work out, it's not a good thing for the public, because a lot of people's retirement accounts are in this thing. A lot of people's, I don't think it's going to be good.
Yeah, I mean, a major, if the AI bubble does pop, it will be a very significant drag on both equity markets and finances more broadly. There's lots of corporate bonds and private credit that's sort of bound up in it too, because of the different deals that have been cut. So the world in which this pops is going to be pretty gnarly economically. I don't think there's any question about that.
But what will be left, going back to your question, I can't really say, because in the past there's been AI summers and AI winters, right? So what has happened is most of the people involved there weren't that many VCs, because the venture capitalist system is a more recent system, right? It was more governments and military, and a lot of these things were being invested in during the Vietnam War, for example, for computer vision and other things. So once people, you had AI summers where a lot of money was being thrown at it. But once they overhyped, right, and under delivered, and then what would happen is people just didn't want to do anything in AI. So then all the people in computer vision or whatever who called themselves AI went back to saying, I'm not AI, I'm computer vision, because the AI people are the ones that just hype things. So we could go back to that. AI just becomes a bad word, then I don't know what happens to my institute, because it's like the AI Research Institute. I don't know. Maybe we rebrand, and then everybody kind of goes back to doing more task specific things. Hopefully, or I don't know, because all of these data centers are being built. They might feel like they have to use it for something and push something else down our throats. I'm not sure what would happen if this thing doesn't pan out. I can't. I'm not a good bettor, like you said.
Yeah,
Yeah.
yeah. I mean that it's sort of daunting to even conceive of it just in terms of those the physical infrastructure that's being built and the resources that are going into it
Yeah.
and what it will mean. Timnit Gebru is a founder and executive director of the Distributed AI Research Institute, also known as the DARE Institute, former co-lead of the ethical AI research team at Google. That was so fascinating. Thank you so much. I really, really appreciate it.
Thank you for having me.